Welcome! My name is Felix and I'm presenting Stepwise Immersive Scene Generation with Multiview Panoramas. Our goal in this project is to build a pipeline to generate highly detailed and explorable 3D scenes from an input panorama for VR applications. So, for example, we want to go from an input panorama such as this one to an explorable scene such as this one. There are multiple requirements for this final scene. First, the scene should be highly detailed and consistent. Second, the scene should be valid in all directions, 360 degrees. And third, the scene should be walkable in an area of roughly 2 by 2 meters, which corresponds to the typical VR application. There are several recent approaches that tackle the same problem. First, there's World Explorer. Here, the authors use a video generation model to generate multiple exploration videos through the scene. The generated videos are conditioned on a camera trajectory, reprojected depths, and frames from previously generated videos. While the approach is quite elegant, the videos often only observe a small portion of the scene and are thus not very consistent among each other. Therefore, the final scene often has many artifacts. The second approach is called Layer Panorama 3D. Here, the authors use a segmentation and depth prediction model to generate multiple layers of panoramas, similar to a multiplane image. And these layers are then lifted to a 3D Gaussian splatting to obtain an explorable scene. Unfortunately, this layering mechanism is not very robust, and the final scenes often have severe artifacts. However, if it works, the results are quite impressive. The third approach is called Matrix 3D. At the core of Matrix 3D is a fine-tuned video generation model which generates panoramic videos. Using this panoramic video generation model, the method explores the scene in several directions and then lifts everything to 3D Gaussian splatting. Unfortunately, panoramas require really high resolution, which is not possible to achieve with standard video generation models, which means that the final scenes are often very blurry. However, because they use panoramic videos, the consistency tends to be really good. So how does our approach Stepper work? Taking inspiration from the baselines, especially from Matrix 3D, we develop two main intuitions. First, we realize that panoramas are a very powerful representation to encode the entire scene context in an elegant way. Therefore, we aim to operate directly on panoramas. Secondly, from Matrix 3D, we realize that panoramas need to have a really high resolution to retain all the details and to ensure that the final scene is of high quality. Therefore, we aim to operate on high-resolution single views rather than panoramic videos, which always have a resolution trade-off. This leads us to our approach. At the core, we have a model which allows us to generate a novel panoramic view of the scene conditioned on an input panorama. Specifically, the novel view is generated at a certain distance d moved forward from the input panorama, sort of taking a step into the scene. Importantly, because we only generate a single novel view, we can apply the model at a really high resolution of 2K by 4K pixels, which is significantly higher than what is possible with any current video generation model. Using our stepper model, we can then explore the scene in several directions, starting from an initial panorama. All of the generated panorama views are then reconstructed using MapAnything and used to optimize a 3D Gaussian splatting scene, which we can then explore. To design our novel panorama view generation model, we take inspiration from the recent approach called CubeDiff. Here, Panoramas are represented using their cube map. That means using 6 regular perspective images. We extend this to have a double cube map representing on one hand the initial panorama and on the other hand the novel view panorama. Importantly, all of the individual cube faces represent perspective images, which means that we can start our training from a pre-trained image generation model. So how do we train our novel panorama view generation model? Unfortunately, no real-world datasets with multi-view panoramas exist at that scale. Our solution to this problem is that we create a synthetic dataset using Blender and procedural scene generation with a modified Infinigen framework. Our final Stepper dataset contains 5,000 scenes and 230,000 panorama pairs in total, all generated at a 2K by 4K resolution using high-quality ray tracing. So let's take a look at some results. Here we see the initial panorama, from which we take 2 autoregressive steps to the left and 2 autoregressive steps to the right. If we zoom in here, we can see that, for example, this small table with the figure on top gets correctly rotated and the empty previously occluded space is correctly filled in. Same goes for the other side. Here, the chair is correctly rotated according to the viewpoint change and the occluded areas are filled in. Importantly, all the details are still retained in the novel views. So now let's check out some real 3D results. Here, starting from this initial panorama, we compare all 3 baselines against our method. Our approach produces a really high quality 3D scene with consistent geometry and a lot of details. Matrix 3D also gives a very consistent scene. However, due to the low resolution of the panoramic videos, the final scene is also quite blurry. In Layer Panorama 3D, we can observe that the layering mechanism failed and produced a lot of artifacts in the final scene. Similarly, in World Explorer, there was a lot of inconsistency in the generated videos, and the final scene contains a lot of floater artifacts. We can observe the same thing for this outdoor scene right here. Stepper generates a really high quality scene with very high level of detail. Matrix 3D also achieves strong consistency. However, the overall scene is quite blurry. For Layer Panorama 3D, again, the layering mechanism struggles and removes major aspects of the scene, for example, the house. World Explorer again contains many Gaussian floater artifacts, which are a result of video inconsistencies. This was Stepper, Stepwise Immersive Scene Generation with Multiview Panoramas. We propose a multi-view high-resolution panorama diffusion model for iterative scene expansion. We propose a robust reconstruction framework that synthesizes generated multi-view panoramas into a consistent, explorable 3D Gaussian splatting scene. And we propose a large-scale multi-view panorama dataset together with a benchmark set for evaluation of scene generation methods. Please check out our project page for more details and more qualitative results. Thank you very much for your attention.